Okay, so this is the question given to us. Now, they said we should use Newton's divider method to solve this question. Now, from here, they give us x, the values of x and y. Y from this question is also the same thing as f of x. Y is equal to f of x. So don't get confused that where is your f of x, y is the same thing as f of x. So the first thing you do is to put it in a tabular form. So like I said, put it in a tabular form. After doing that, now the next thing to do is to find to what degree you're going to get your p, like at what value. Are you stopping at p3 or p4? That's what I mean. So now the best way to do that is to cross this your y or x together, like the way you do in probability. So this is what I mean. This and this, this and this, this and this. So now from here, since I've crossed this, what this will give me is this is x1 and x0 from here. So this is x1 comma x0. Now the next one is between 2 and 1. So this is x2 comma x1. And next one is between 3 and 2. This is x3 comma x2. Now I'll do the same thing for this again. Across these two, across these two. So now this will give me what? x2, x1 and x0. This is x2, x1 and x0. Now this will be x3 comma x2 comma x1, because these are the variables present in this data. So now I'm left to just one more cross, this and this, because after this I cannot cross anything again. So now what is the data for this one? This is x3, x2, x1 and x0. So now what this is showing me is that I'm going to stop at p3, because this one has what the highest number here is what, 3. That means I'm stopping at p3 to a function of what, x. But if peradventure this was here, it means I'm going to stop at what, p2. So this already has given me an idea of where I'm going to calculate to, like to what extent I'm going to calculate to. So the next thing you need to do is to find this, the f of x of this. That is 1, 2, 3, 4, 5, 6. Now I'll now substitute everything into my p3. Now you can see that from here, this is a linear interpolant, this is a quadratic interpolant, and this is a third order polynomial. This is the same thing as the first order polynomial, second order polynomial and third order polynomial from the equation I gave to you. So all you need to do is just bring out your third order polynomial equation and substitute it into it, and you're good to go. So the formula is p3 of x equals to, so here's the formula. So this is, I need to find this, I need to find this, I need to find this, which is the same thing as all of this. So let's start with the linear interpolant. So the first one is f of x1 comma x0. Remember I said draw your range. So your range is the difference of your range, which is what, x1 minus x0. That is your denominator. Your numerator becomes your f of x1 minus f of x0. Now the reason why this is having just one variable is because you know this is a linear interpolant. That's your what, p1, isn't it? So your p1 indicating one interpolant. If it was p2, it's going to indicate what, two interpolants. I'm sorry, two variables. If it's p1, it is one variable. If it is p2, it is two variables. If it is p3, it is three variables. That is why this is what, one variable, because it's p1. So from here, you know your f of x1 from here. This is x1. This is x1. So f of x1 will be this. That's 3.6269 minus the f of x0 is this one, because this is x0. So f of x0 is this one. The x1 is 2.1 and the x0 is 1.8. So I'll do the same thing for x2, x1 and x3, x2 shortly. So when you solve it, this is what you get. The first one 2.28, 8.30, 3.36, all approximated to the nearest second dp decimal point. Alright, so we're going to move to the quadratic interpolant now. So this is the quadratic interpolant. Now remember I said the first thing, draw a line, find the difference of the range, that is x2 minus what? x0. Now this quadratic interpolant falls under what? P2. So it means that there are going to be what? Two variables, two functions of variables here. So it's going to be f of x2 comma x1 first minus f of x1 comma x0. Simple. This is how it's going to be. So the next thing, since you've gotten these values, just all you need to do is just substitute and find your answer. So I'll do it for the second one as well. So when you solve the quadratic interpolant, these are the values you get: 15.05 and minus 12.35. So move to the last one, which is the third polynomial, third degree polynomial. Is what? Find the range. The range is between x3 to x0. That's x3 minus x0. Now since this is a third degree, it means that your function is going to have what? Three variables. So that becomes f of x3 comma x2 comma x1 minus f of x2 comma x1 comma x0. Shaking up. All I just need to do is substitute the values, and that's all. So after solving, this is the value you get. So we've gotten all the values that we need. Now the next thing is to substitute it into our P3 and we're good to go. So this is it. Now all we need to do is substitute, and they give us the value of x to be 2.3 in the question. So anyway, we see x, we just put 2.3. So we know our f of x0 to be from the question. F of x0 is 2 plus, so your P3 when x is equals to 2.3, after solving it will give you what? 5.1958, and that's it. So but you can check, I don't know, maybe my calculator give me, but just solve it by yourself, you should get this answer as well. Alright, thank you.